All right, guys. So today we got lesson 10.3. We're going to go over properties of chords. Now, if you remember, a chord is a segment in a circle that's endpoints are somewhere on the circle. So we have our endpoints on the circle. So if we're looking at here, we have a semicircle. It is a chord, and you see my endpoints. They are on the circle, and a semicircle basically creates a diameter. So that is my chord. Also, if you look at just any other chord that is not a diameter, it creates a semicircle. That, again, the endpoints are on the circle. And what it does is that since it's not a diameter, you will have one part that's a minor arc. And if you remember that, it's less than 180 degrees. And we'll have a major arc created as well, which is greater than 180 degrees. So that's just a review of chords in general, what type of chords we're going to see. So you have ones that are not a diameter, and then you have the ones that are a diameter, which create a semicircle, which means we know it's 180 degrees each time. So our first theorem that goes with chords is that in a circle, if two minor arcs are congruent, if and only if their corresponding chords are congruent, that basically means, guys, if we're in one circle or two different circles, that what you see here is that my chords here, BA and CD, they are congruent, then the minor arcs they create, arc BA and arc CD, are also congruent. And it works both ways. So if you know the arcs congruent, you know the chords that create them are congruent. The only other one is that if you're in two different circles, and they would be the same. So if I was to show you this, where maybe I create a circle here, and I'm going to just clone it. So we know that the two circles are congruent. And if I did, this there and called this AB, and then did the exact same thing over here and did like CD, since my two circles are congruent and I knew that A and B was congruent to CD, then I also know that the arc AB is congruent to the arc CD. So we see that they're the same no matter what, even if they're in one circle versus two circles. So here is an application problem to this. And this is what you're going to see in your homeworks and everything like that. So the first question is, given my circle D here, and we see we have chord AB and chord BC, and we see that the lengths of each of those are 9. It's saying if AB is 110, then what is BC? Well, since I know my chords are the same length, which means they are congruent, then I know that the arcs that they create are congruent. So if AB is 110, then that tells me that BC has to be 110. And then the second question, which is unrelated to the first, says, given AC is 150, what would BC be? Well, I'm going to erase my previous problem just on that part. I'm going to leave the tick marks and everything because that's not changing. And it's telling me that AC, so this arc down here on the bottom, is 150. And it wants to know, what is BC? So it's X. But if BC is X, that also means that AB is X. And that was a very bad X. And now we know that a circle is 360 degrees around. So to solve for X, it's X plus 150 equals 360. So 2X plus 150 equals 360. So 2X equals 210. So X equals 105. So my answer is 105 degrees. All right. The next theorem that we encounter with chords is if one chord is perpendicular bisector of another chord, then the first chord is a diameter. So we look at my diagram here, and we're basically saying, all right, here we go. We got Q, S, R, and T, right? If QS is a perpendicular, again, that's what the upside down T means, bisector of TR, then QS is a diameter, which basically means that it passes right through the center, right? So if QS is a perpendicular bisector, so it's perpendicular by the square part, and TP and PR are congruent, right? Then we know it's a diameter, which means that QTP is 180, SRQ is 180, and such and so forth. And then our next theorem that we get with this is if the diameter is perpendicular to a chord, then the diameter bisects the chord and its arc. So it adds a little bit to it. So firsthand we said, all right, perpendicular bisector, one's perpendicular bisector to the other, it is a diameter. This one's kind of a little bit on the other way. It's kind of like the converse. So remember to switch your hypothesis and conclusion. If the diameter is perpendicular, so we know this is a diameter, so we know it goes through the center. So EG would be a diameter, and it is perpendicular to FD. And so what that tells us is that FH and DH are congruent, but it also tells us that my arcs, FG and GD are congruent, but that also tells me that EF and ED are congruent. Because again, since EG is a diameter, if I told you that FG was 30 degrees, then that does mean that EF would be 150. And since GD would be the same, that would be 30, and that would be 150. So those are just example numbers. Again, that doesn't necessarily mean they're going to be that, but that's what ends up happening. So again, if a diameter has to be a diameter. Now, that also can include radii, because again, remember, half a diameter is a radius. So we can even put the radius in here and just say, if a radius is perpendicular to a chord, then it's going to cut the chord at its midpoint, or bisects the chord, and it also bisects that arc that's created by that chord. We may not see the other side unless we extend the radius to make a diameter. This also includes radii. So be aware that radiuses are also in this, and you're going to see that in your problems on your homework and everything. So 2 examples that deal with this. All right, my first one here is I've gotten BD and I got CA, and we see that BD is a diameter because it goes through the center, and that CA is perpendicular to it. So what does that tell me? Well, it tells me that it bisects CA. So each part is congruent, and since the lower half is 7, that means the upper half has to be 7. And since the question is asking what is CA, how far is the whole thing, we just add 7 and 7 and we get 14. Looking at the second one, we have perpendicular, right? And we're going to assume this is the diameter as well. It's a perpendicular, so what's happening is that since it's perpendicular, it bisects it, which means these 2 segments are congruent, which also means now that my arcs are congruent as well. So I know that 9x and 80 minus x are equal to each other. So I'm going to set them equal and solve for x. So 9x equals 80 minus x. Add x to both sides, you get 10x equals 80. And so x equals 8. Now I can find my arc CD and my arc DE. So I'm just going to plug 8 in. 9 times 8. That should be obviously, that is 72. And since CD is 72, that means DE has to be 72. That's what we're saying. And if I wanted to find CE, just as an extra thing, what would CE be? And we would say that'd be 144. And if I really wanted to test you guys out, I could go, oh, what's the measure of arc CBE? And that would be 144 out of 360, and so you'd end up with 216. So if I really wanted to do it. So expect that type of problem you're going to see again. Quiz, test, all those good things. Maybe I have to. Our next theorem, and I may be going quick, but again, pause the video when you need it. It says in the same circle, so or congruent circle. So this is kind of like the first one we did. Two chords are congruent if and only if they are equidistant from the center. And remember, we measure distance as a segment that is perpendicular from the object to a given point, or a point to the object, and that segment has to be perpendicular. So if you remember when we did angled bisectors, a point on the angled bisector had to be equidistant from the sides, and then the line from the bisector had to be perpendicular as well as congruent. Sorry about that.
Please reconvene in the Learning Commons. Thank you.
Sorry about that announcement. We're going to have to go here, but I'll finish up soon. Two chords congruent if they're equidistant from the center. So we get this, and so we see that AB is congruent to CD. So my chord here, AB, is congruent to AB, is congruent to DC, because they're both equidistant from E. And so a couple examples here on this is that if we get this 2x, we see that QR is 16, ST is 16. Since they are congruent, then we know that UC and BC are congruent because it's the if and only if, so it works both ways. So we can set 2x equals to 5x minus 9, which is negative 3x equals negative 9, x equals 3. And then if I want CU, it's just plug in 3, which ends up being 6. And on the second one, it's telling us, hey, look, we see PV and PW, they're congruent and perpendicular. So we know that my two chords are congruent, which means the arc is congruent as sound. So QR is 2x plus 6, ST is 3x minus 1. So we set them equal to each other. And we end up with x equals 7. And so if we figure out QR, that's 2 times 7 plus 6, which ends up being 20. All right. So if you have any questions, please email me, and we'll go over everything later.